This video is brought to you by IXL, used by millions of students worldwide to get ahead in math, English, and more.
Let's match polynomials and graphs. But first, a reminder on how to classify polynomials. Each term in a polynomial has a degree, the exponent on its variable. To find the degree of a polynomial, find the term with the largest degree. A polynomial is quadratic if it has a degree of 2, cubic if it has a degree of 3, and quartic if it has a degree of 4. Match each polynomial function to its graph. F of x equals x squared minus 8x plus 19, and g of x equals negative x squared plus 4x minus 10. Okay, we have two polynomials, but what type of polynomials are they? Let's look at the term with the largest degree. F of x is quadratic, and g of x is also quadratic. Great, the functions are both quadratic. The graph of a quadratic function is a parabola. A parabola can either open up like this, or down like this. We just need to look at the leading coefficient of the square term to figure out which way it opens. If the leading coefficient is positive, the parabola opens up. If it is negative, the parabola opens down. For f of x, the leading coefficient is positive 1. For g of x, the leading coefficient is negative 1. The leading coefficient of f of x is positive, so its graph opens up. The leading coefficient of g of x is negative, so its graph opens down. That means f of x must be the graph on the right, and g of x must be the graph on the left. Let's look at another. Match each polynomial function to its graph. This time we have two polynomials and their factored forms. The term in each function with the largest degree has a degree of 3. So both f of x and g of x are cubic functions. Cubic functions have one of 3 shapes: this, this, and this. And these can either be increasing as x goes to infinity, or decreasing. Let's look at the cubic terms. If the leading coefficient is positive, the graph increases as x goes to infinity. If it is negative, the graph decreases as x goes to infinity. But both f of x and g of x have leading coefficients of negative 1. It looks like both graphs are decreasing as x goes to infinity. So this time the leading coefficients won't help us. So instead, let's look at the zeros of each function. The graph on the left touches the x-axis twice, so it has 2 zeros. The graph on the right touches the x-axis once. It has 1 zero. So to determine which function describes which graph, we can find the number of zeros for each. First, let's set f of x equal to 0. The factored form will be much easier to use here. Negative x minus 7 cubed equals 0. This function has one real zero at x equals 7. So the function intersects the x-axis once at x equals 7. That matches the graph on the right. Now let's set g of x equal to 0. Negative x plus 8 times x plus 6 squared equals 0. This function has 2 real zeros, one at x equals negative 8, and one at x equals negative 6. So the function intersects the x-axis twice at x equals negative 8 and x equals negative 6. That matches the graph on the left. That means f of x must be the graph on the right, and g of x must be the graph on the left. How about this one? Match each polynomial function to its graph. 4 polynomials and 4 graphs. Okay, first let's classify each polynomial by its type. F of x has a term with a degree of 4, so it is a quartic polynomial. G of x has a term with a degree of 3, so it is a cubic polynomial. h of x is another quartic polynomial. K of x is another cubic polynomial. Two functions are cubic and two functions are quartic. Let's start with the cubic functions. There are two graphs that look like they could be cubic functions. One is increasing as x goes to infinity, and one is decreasing as x goes to infinity. For g of x, the leading coefficient is -1, and for k of x, the leading coefficient is +1. The leading coefficient of g of x is negative, so its graph decreases as x goes to infinity. The leading coefficient of k of x is positive, so its graph increases as x goes to infinity. That means g of x must be the third graph, and k of x must be the first graph. The graph of a quartic function has one of many different shapes that either open up or open down. And some of them look a lot like parabolas, so be careful you don't assume they are quadratic. If the leading coefficient is positive, the graph opens up. If it is negative, the graph opens down. To determine which function describes which graph, we can look at their leading coefficients. The leading coefficient of f of x is negative, so its graph opens down. The leading coefficient of h of x is positive, so the graph opens up. That means f of x must be the second graph, and h of x must be the last graph. This is a case where a quartic function looks a lot like a parabola, but it is not a quadratic function. It's quartic. One more. Match each polynomial function to its graph. Here we have 4 polynomials again, and their factored forms. First, let's classify each polynomial by its type. F of x has a term with a degree of 4, so it is a quartic polynomial. G of x has a squared term for its largest degree, so it is a quadratic polynomial. H of x is a cubic polynomial, and k of x is a quartic polynomial. Only one function is quadratic, so we can try to match that one right away. The second graph could either be quadratic or quartic, but it's the only graph that can be quadratic, so this must be the graph of g of x. Only one function is cubic, so let's do that next. The third graph is the only graph with the shape of a cubic function, so this must be the graph of h of x. The last two functions are quartic, and they both have a positive leading coefficient. So once again, the leading coefficients won't help us since both functions open up. So instead, let's look at the zeros of each function. Let's first set f of x equal to 0. The factored form will be much easier here. This function has 3 real zeros at x equals 0, x equals 2, and x equals 3. 2 of these zeros are positive, and 1 is at the origin. That means f of x must be the last graph. Now let's set k of x equal to 0. This function also has 3 real zeros. X equals -2, x equals -1, and x equals 0. 2 are negative, and 1 is at the origin. That means k of x must be the first graph. And we did it! We matched all 4 functions to their graphs. Great job! You can do this!
Head over to IXL.com for more practice on this skill and thousands more videos in math and language arts.